Hi, I'm Laszlo, and this afternoon I'm going to show you how to clean properly a gold electrode for DNA deposition. What you need to know that there are three steps involved in this process. Step number one is the electrochemical cleaning. Step number two, the mechanical polishing, and step number three is the electrochemical polishing. So, as I mentioned before, in order to obtain this good clean electrode, first you need to do this electrochemical cleaning. For this you need 0.5 molar sodium hydroxide, which I already prepared. You need this glass cell, and actually to put some of this sodium hydroxide in it. Next, you take this gold electrode, you fill it with a holder, open the Faraday cage. I already put the reference electrode and the counter electrode. As you can see, they are already connected. You place the cell inside and you close it. Next, you connect the working electrode and then place it inside. Just like this. Make sure you close the door. Next, you will run cyclic voltometers, 10 cycles, starting from 0.4 volts all the way to minus 1.6 volts. And the scan rate is 50 millivolts per second. And that's step number one. So in step number two, first we take the electrode from the cleaning, we wash it with DI water, clean it with a clean wipe. Next, we will actually do the mechanical polishing. So for this, you need a 1 micrometer diamond paste and a 0.1 micrometer aluminum slurry. And you need a polishing pad. So once you put each and one of them in onto this pad, you take the gold electrode and then you start polishing for 2 minutes. And what you need to do is you have to draw 8s all the time. Once you finish with the diamond, you wash it and then you do it with the alumina. And again, do it for 2 more minutes. After the mechanical polishing, you sonicate the electrode in ethanol and water in 1:1 ratio, at least for 10 minutes. So we arrived at step number 3. This is the electrochemical polishing. This is actually contains of 2 steps. Step number 1, you place the electrode into 1 molar sulfuric acid and you run cyclic voltometers. Next, you put it in 1 molar sulfuric acid with 10 millimolar potassium chloride. And for the final step, you actually place the electrodes into 0.1 molar sulfuric acid. And this is only just for you to calculate the electrochemical surface area of the electrode. So, when you are running the CVs in 1 molar sulfuric acid, this is what you should get. And in this case, you are actually running 10 cycles from minus 0.3 volts all the way to 1.7 volts. And the scan rate is 300 millivolts per second. So when you're running the CVs in 1 molar sulfuric acid with 10 millimolar potassium chloride, this is how it should look like. In this case, you're running the CV from 0 to 1.7 volts and the scan rate is 300 millivolts per second. And you do this 10 times. So, in the final step, when you run the CV in 0.1 molar sulfuric acid, this is what you should obtain. And this CV was obtained between 0 and 1 volts, and the scan rate is 300 millivolts per second. From this CV, you can actually obtain the electrochemical surface area of your clean gold electrode. You know if it's clean when these 2 shoulders are symmetrical. If it's lagging, then you should start all over again because the electrode is not clean. So now you know how to clean a gold electrode, and now you theoretically have a nice clean electrode. Good luck guys with your measurements.